Very good afternoon. My name is Alok and I welcome you once again to Networknuts YouTube channel. A very interesting video this time, and as you can see the heading here, increasing the Linux performance by 25 to 30%. Is this really uh, uh, means a right title for the video, or it's just a hype? Actually, you can. I'm going to share with you two things. One is already there, but you are not knowing about that. And the second thing you need to configure. Two things, if you do it on your Linux servers, it is definitely going to increase the performance of your server by at least, if not 30%, then in between anything by 25 to 30%. So we need to first understand what exactly we are going to do and what will happen if we are not going to tune these features or these options, right? So first, remember one thing. The first thing that I'm going to explain you about understanding relatime mount option in fstab. You should understand this. What actually happens? Look, the POSIX standards, that is portable operating system interface, the POSIX standards for all the operating systems, they mandates that the operating system should maintain a file system metadata that record whenever a file was being last accessed or modified or changed. Okay, let me write it here. POSIX standards, POSIX family of standards for operating systems require that operating system must maintain a file system metadata that records each time when a file was last accessed, last modified, or last changed. So it is a standard that the operating system need to maintain a separate file system metadata for every file, that when the file was last accessed, when it was modified, or when it was changed. So you can easily see it by the stat command. Let me explain you what happens. I have a graphical interface for you. Here it is. So the POSIX standard says, let me use the pencil. Yeah. So the POSIX standard says, let's suppose this is your hard disk. Say this is my hard disk. It is my hard disk. And here I have got couple of files. Here I've got many files here. Some files are written on my hard disk of different sizes, like this. And I, being a user, is trying to access a file. Let's suppose I'm trying to access this file. Let's say I'm trying to access this file, the file in green. So what actually happens? It is your hard disk. Apart from the inode information and all the things related to the files, the operating system need to maintain a separate file system metadata. Means my operating system is also supposed to store a parallel file system metadata for each and every file. For each and every file, a metadata is to be written like this. For each and every file, a separate file system metadata is to be maintained. That means if I am accessing this file, so the metadata will be containing information about this. Let's suppose I had created this file today, so it will contain the ctime, that is 15th of April, and the date and time and the seconds. and access time we call it atime, so it will also be the same 042014, and then mtime, the modified time, right, when the file was modified. So for every file it need to maintain a separate file system metadata. Fine, so let's suppose I had created this file, so all this entry related to this file has been stored in the file system metadata. Now say tomorrow or after half an hour, it also contains the time. Let me give the time also. So it also like contain the time. So right now it is 1442, 1424, 1424 and some seconds, 001, like this. So it contains the actual timestamp when the file was being created, when the file was being modified and accessed, right? Just a moment. So it contains this kind of information. That makes sense. It actually makes sense, so that I know that when the file was being created, accessed or modified. That sounds good to me. But what happens, say after 15 minutes, I'm just trying to cat this file. I just done a cat of this file, say cat and the file name, file1 file name. I just given the cat and the file name for this file. So I'm merely viewing the file. It is a read request. So prior to rel 5, what happened? Though it was a read request, fine, you had given the cat command, the output was displayed on the screen, but the file system has got another job to do, that it need to modify the atime, access time. So it will go here. I'm just making it more dramatic. It will, where is the eraser? Just a moment. Yeah, it will go here after 15 minutes of time. It will go here, remove the access time like this, right, and then write the new time. So every time you read a file, the operating system need to do all these things. So and then it reads the new time. Say it writes here 1455 or 44, like this, 0001. So a read request is actually a write request. So it consumes a lot of time. So every time the user is reading a file, fair enough, he is reading a file. So I am just doing a read here. So I am reading the file, but the metadata has been modified every time. So it consumes a lot of resources, right? So, but we need to stop this. Fine, access time should be modified, but not. So, I'm sorry. The creation time or the modification time should be modified, but why the access time? Why? Because it is merely a read request. So read takes very less resources, but for a read it is actually a write for the operating system in the background. So what happens actually, I'll come back here. So I can write here, right? Okay. So the access time is called atime, A for access, the creation time, or say the modification time, is called mtime, that is M for modification. The creation time is called ctime, C for creation, for create. And you can view all this information by the simple stat command. Let me show you. But so prior to rel 6, every read was not a read. It's a write operation, right? I hope you are understanding this thing. It's a write operation for OS since the atime need to be modified in file system metadata. Though it seems good, but it is actually, so doing a write for every read is nonsense, isn't it? So doing a write for every read is nonsense. The right word is nonsense. It's a bad idea. I can say bad idea also. And it really sap your performance. Sap your performance. Just a moment. So it is, and I will show you. Okay, here it is. I've got a file here, testing realtime.txt. So I just cat this file. That's great. And I give a stat command, stat testing realtime.txt. So as you can see there, the file was created on 1341. Right now the time is 1429, but it is not being modified. 1429 is not coming there. It was when the last time I had modified this. So it is how. So whenever prior to rel 6, what was happening, every time you was doing a cat or you are reading some library file, even from the cache, the access time was modified by the operating system every time. So it was giving a unnecessary load on the operating system, right? Now if I modify this, say this makes sense, and this one for you, and I save and come out. Now I give the stat command. You can see the current time 1430 is coming now. It has changed straight away. Now when you had written on your data file, the metadata file system is, the file system metadata is also modified, but now it is happening only when you are writing something, not reading something. So by default your rel 6, okay, I will just write here. So by default, you never know this, by default rel 6 uses relatime mount option. So what it does, very simple. So using relatime is a better option, I can say, as it updates the atime only when the file or directory is being modified since last atime change. So that means when you are reading the file now, only reading it, not modifying it, there will be no write job on the file system metadata, right? So with relatime, I can write here, atime data is not written every time the file is read or accessed. Atime data is written to disk when the file is modified, right? Or, very important, or I can make a space here, or the file is accessed more than a certain period of time. After more than a file is accessed, I can write here after more than a certain period of time. So in rel 6 it is 1 day. That means either the atime will change only either you have changed the contents of the file or you are accessing the time after 1 day. So if you are accessing the same file 100 times in a single day, the atime will not be modified. So that is definitely going to increase your performance, definitely going to increase, and especially on the servers where there are thousands of read and write requests. How can I be sure? Because we had never used the relatime file option or the mount option also in rel 6, and we had completed our RSC and other certifications. Let me show you. If I give the cat etc fstab, you can see there still I'm using the defaults. Have you ever wondered or questioned what are the default mount options? Default means that some features or some mount options are by default used. There's a very simple way of using it. It's cat proc mounts. Just give this command, press enter, and you can see here these are the options with which the file system is mounted when you use the defaults in the etc fstab. Now you know it. Just a moment, friends. Just a moment. Let me increase the width for you. Yeah, makes sense. I'll do it again. See here. Here is my root slash. So slash, the fstab is saying default, but it is being, the file system is ext4 read write relatime option, and your tmpfs it is relatime option. Your boot is a separate partition. If I give a df-h here, see, so I've got three different file system boot. So the boot here it is also mounted with a relatime file option, mount option, sorry, and your slash or root is also mounted with a relatime mount option. So by default it is there in rel 6, but if you are not using rel 6, using rel 5 or any other earlier version of Linux, please use relatime in your fstab. That means, so if you are using, I can using earlier versions of rel like 5 or 4, please use relatime mount option for mounting file systems in etc fstab, right? So what you need to do, nothing, just your device, say dev, I'll just give a simple example here, say dev sda1 anything, say a mount point, then gives your ext4, then gives defaults, and right here relatime. That's it, and 00 or 12, whatever. You should use this, and at any time you wish to and you don't want to use the relatime mount option, though I will never recommend it, you can suppress it by using no relatime instead of relatime. right? So it should be the first map, the first thing for the performance of your operating system. Just check cat proc mounts and make sure that against all your file systems relatime should be there. It is by default there in rel 6. I'm repeating it again, but you need to check it on rel 5 or other prior versions of rel. So first thing that you should be doing is that please make sure you use the relatime file option. And I hope you understand the basic idea behind the your relatime, that whenever you do a cat or you read a file, if the relatime is not there, then even the file system changes, the access time will be modified, right? You see here it is now modified because it will be modified only once, so that the access time should be having a bigger value than the modified time or the change time. Now it will not change till one day. So you keep on like doing the cat on the same file, but no file system metadata changes will be written by the file system. So you are significantly reducing the IO and the load on the operating system. Consider it for a say high activity server, how much effect on performance it can lead to, right? I will use the same command again after 5 or 10 minutes to show you. The second option, the second thing that you should be doing is that using the barriers. So the first thing is that using the relatime, understanding relatime mount option, and the second thing is that understanding barrier mount option in etc fstab. If you see here, when I'm giving this cat proc mount, there is one option is coming up, barrier 1. It is against my root. The same is there for the boot, barrier 1. What is this barrier? Barrier, okay, let me write. Here it is, understanding the barrier, right? So barrier actually controls your JBD, generaling block device. Control JBD, that is generaling block device. So what actually it does, it makes sure, the barrier makes sure barrier can have two values, one for enable and 0 for disable. What it does actually, now we need to know what it does. Fine, by default it is enabled. So barrier 1, if it is 1, that means the file system enforce a proper general commit. File system enforce a proper general commit. So it is actually used, I can write here, it is actually used to reduce the data corruption chances in case of power failure. Now read this, in case of power failure, but we nowadays have all the servers and our laptops have got battery backed up, right? But nowadays all the servers are battery backed up in any way, in one way or other, in one way or other. Either you've got an online UPS connected or anything. So we have got the battery backed up. Our servers and especially our laptops, they are now battery backed up, right? So that means I need not to care about the power failure. What will happen if I am writing something and the power goes off straight away and the file system general was not committed? So barrier 1 was to make sure that the general should be committed before it actually flushes the write cache, right? So enabling write barrier means, so I can write here for you, enabling write barrier, that is barrier equal to 1, means that means constantly flushing write cache, and it actually reduces your performance. It actually reduces your performance. So we don't need actually, but the point is that the kernel doesn't have any way to find out whether your server is battery backed up or not. So just to make sure and for a safe side or a safe configuration, Red Hat has by default made the barrier active, so that in case of a power failure, the operating system makes sure that the generals are being flushed and being written into the disk, right? So on a proper battery backed up machine, I don't need this. So you can safely disable this. Let me show it to you. So in my case, so I can safely disable the barrier, right, on a proper battery backed up machine like laptops or servers to safely improve performance. Safely improve performance. So what I need to do, I just need to modify the etc fstab and make it barrier 0. So I will just show it to you in my root. So I go to etc fstab against my root, because it's a battery backed up machine. I can write here barrier equal to 0. That's it. Save and come out, and I can do a mount -o remount slash, and if I give a cat proc mounts, barrier is 0. See here. So by giving the barrier 0, I had increased the performance of the machine significantly, because now the machine need not to constantly flush the write cache. So doing these two things will definitely going to significantly increase your performance of the file system by at least by 22 or from 25 to 30%. So make sure that you use the real-time mount option, which is there in case of RHEL 6, in case you are using a RHEL 6. So it is one of the reasons why you should use the latest operating system, because they have come up with the new thing and the latest things by seeing the disadvantages of using the atime, right? So always use the latest kernel, the latest OS, so the new features, because this feature is already there. We never knew this, that it actually exists, and it is actually making our lives much more easier. But you should know all these finer and the detailed points within the file systems. So make sure that you are using the real-time, and the barrier can be safely marked as 0, or you can disable the JBD, journaling block device, in case your machine is properly battery backed up. So I hope you liked the video, and thank you once again. Thank you very much. God bless. Take care. See you again soon. Bye. Ciao. Hooah.